So this lesson we're going to be talking about interval estimation or confidence intervals, but we're going to be using something called the t-distribution. The items needed for this lesson are going to be your TI-83 calculator, the t-chart unedited version I'm going to supply for you, and then the t-chart edited version that is going to be a download that you're going to have from the website, and you're going to see it's going to say just simply t-distribution chart. Alright, so here's what we're going to need. So we're going to be creating confidence intervals. And we're going to be creating these, but our sample sizes are going to be smaller than the minimum required of 30 that we normally have. Small samples are sometimes necessary due to certain situations. Like, for example, if a research hospital wants to know if a new drug will help a patient with a certain disease, then the researchers typically give the drug to a small sample of patients to make sure any potential side effects are minimized. So you wouldn't want to give anything, a drug to a sample size larger than 30, just in case something happens with the drug and there's a bad side effect. You have a large population with that side effect, so you keep it kind of small. So in this lesson we'll be constructed still again our 90 and 95 and 99% confidence intervals, but we're going to be using something known as a t-distribution. We'll need a new chart, which we talked about up above, and you're going to download this chart like I just said a second ago. Alright, so we're going to need to know two things based on the chart that you're going to download. You need to know something known as DF, and that's called degrees of freedom. And you also need to know the area in the right tail. And the area in the right tail is based on the actual confidence interval being asked for. I'm going to explain that in just a second, but a 90% confidence interval will have a 5% in the right tail, a 95 will have a 2.5% in the right tail, and a 99 is going to have a 0.5 in the right tail. I'm going to discuss that a little bit more detail in just a minute. The degree of freedom is based on the sample size. So if the degree of freedom is always one less than the sample. So if a sample has a sample size of 25, our degree of freedom is going to be 24. Let's just say 24. And if a sample size is 15, the degree of freedom is going to be 14. I made a small boo-boo on our notes there. Sample size of 6 will have a degree of freedom of 5. Let me go a little more detail in here for you. For a 90% confidence interval, we need to know two things with the t-chart. One, if we are 90% confident between this point and this point, then you need to know the area in the right tail, and there's 10% left over and each tail gets the same percentage. So you're going to say there is a 5% area in the tail. For a 95% confidence interval, there's 5% left over in the left and the right, and again each gets the same percentage, so you're going to say there's 2.5% in the tail, because the 2.5% and the 2.5% in the left tail will give you 5% that's left over. So 2.5% in the right tail. And for a 99% confidence interval, this one we got to be a little bit more careful. We're 99% confident there's 1% left over in both tails, so there's going to be 0.5%. Now as a decimal, 5% is going to be equal to 0.05. 2.5% is 0.25. Be careful on this one. 0.5% is 0.005. And that's the area in the right tail. Okay. The degree of freedom, which they call DF, degrees of freedom, I like to call this free choices. Let's say you are looking for a new car and there's only 5 choices that you have in the new car. So you have choice number 1, choice number 2, choice number 3, choice number 4, and choice number 5. Those are the only choices that you have to get a new car. And there are only 5 cars that exist. You know, we're just making this up. Well, if I ask somebody which car would you like, and they look at them and stuff like that, they basically would pick one. And that's what I'm going with. Is they're free to choose whichever one they want. So there's a free choice here. So let's say they choose, I would like to, car number 2. So they take car number 2 out for a test drive, and they realize that they don't like car number 2. So, but they were free to choose any one through 5. Then they have 4 choices left to choose from, and let's say they said, well, I like what car number 4 looks like. I go out and test drive it, and now I don't like it anymore. And then they try test, car number 3, and then they try car number 1. Well, what happens is the last choice, whichever the last choice is not free. You're basically stuck with that last choice. So that's where I come up with a degree of freedom. The degree of freedom is always whatever the sample size is minus 1. So if you have a sample size of 5, the degree of freedom is going to be 4. If you have a sample size of 20, the degree of freedom is 19. If you have a sample size of 18, then the degree of freedom is 17. Now, here's the thing. With a T distribution, what they're saying is the minimum, so you sample size is less than 30. That's the definition of using a T distribution. Which means then the maximum sample size is going to be 29. Because that's the largest number less than 30. Which then means the maximum degree of freedom is going to be 1 less than that, which is going to be 28. So that's the largest degree of freedom I can possibly have with a T distribution if we use that kind of rationale. So if I show you, here's the T distribution chart that you're going to download from the website. And you'll notice up on the top, okay, first it says T distribution. And then if you notice here it says area in the right tail under a T distribution. They give you a bell-shaped curve. They give you 0 and T. Now this is a little different than the normal distribution chart because the normal distribution shades in the region between 0 and a z-score. This one they shade in the region, if you notice, in the right tail. So we need to get that area in the right tail to understand what this chart's all about. So if you notice, we just came up a second ago with 3 areas. 0.05, that was the area in the right tail for a 90% confidence interval. So I am going to write above this, I'm going to doctor up this chart a little bit just to make your life easier. 0.05 represents a 90% confidence interval. So all of these numbers are going to be referencing a 90% confidence interval. The 0.025, if you remember, that referenced the 95% confidence interval. And then the 0.005, that was in reference to the 99% confidence interval. So this gives you an idea of which column you're going to reference in relation to which confidence interval is asked for. And then, of course, you're going to go down based on whatever the degree of freedom is. Well, if you notice, this chart goes a lot lower than we need to. We just said a second ago that the highest degree of freedom that we can get from this chart is 28. So we don't need 29 and 30 and 31 and 32. So what I'm going to do is I'm going to doctor up this chart a little more. I'm going to say, well, if I don't need 29, I'm actually going to get rid of 29. So I'm going to put a line through all of these numbers. I don't need these numbers. And then on the bottom 40, I don't need that. And so what I'm going to do is I'm just simply going to just put a line through all of this. And then I'm going to put a big X through that. And I'm just going to write omit. I'm not going to use that whatsoever. The last thing I'm going to do to doctor up this chart to make your life a little nicer is this infinity symbol right here on the bottom. Just to the left of that, I'm going to write this is for anything n greater than or equal to 30. What makes this awesome is if you notice in the last class we had confidence intervals for 90% that had z-scores attached to them. And if you recall, if I notice this column here, the 90% column, when we had sample sizes of 30 or more, we used a z-score of 1.645. For the 95%, which is this column, we used 1.96. And for the 99%, we used 2.57. We used 2.58, but if you notice, there it is, rounded. 2.576 rounds to 2.58, just like 1.645 rounds to 1.65, and that's what we used in the last lesson. So you don't have to memorize those numbers because they're right here in the chart for you. So let me show you how this works when it comes to t-distribution. So let's say we give a situation here. Let's say we want to create a confidence interval. And in creating a confidence interval, we have this scenario. We would like to know, we would like to create a 90% confidence interval with a sample size of 15. Well, eventually we're going to find a mean, we're going to find a standard deviation, and you're going to write the z-score to be data minus mean divided by the standard deviation. And you're going to know what the mean is, and you're going to know what the standard deviation is based on whatever the question tells you. But my concern right now is, what is the z-score? Well, you're going to get that from this. So the 90% confidence interval tells you the column that you're going to use. And the sample size of 15, if the sample size is 15, then the degree of freedom is going to be 1 less than 15, which is 14. And so we're going to go into here, and we're going to put our finger on the 90% column, and we're going to go down to 14. And you notice that right there, that is 1.761, and that's what we're going to use for our z-score. So we're not going to use the 1.65 that we used in the last lesson, because that was only for sample sizes of 30 or more. Because the sample size was smaller, then we go in the t-chart to its degree of freedom. So if we have another situation, we would like to create a 95% confidence interval. The sample size is 22. Well, if the sample size is 22, then the degree of freedom is going to be 1 less than that, which is 21. And a 95% confidence interval, so if we go over here and we put our finger on 95%, and we're saying the degree of freedom is 21, so we're going to go 95%, we're going to go down to 21. We scoot up just a little bit here, and we're looking at right here, 2.080. So we would have a plus and minus 2.080, and then we would continue with this. We're not going to complete this right now because we're just finding the z-score, but that would be the z-score that we would use. And then eventually we'd fill in for the mean and the standard deviation, and then we'd solve that confidence interval. So here's another one. We would like to create a 99% confidence interval, and the sample size is 9. So we know that the degree of freedom is going to be 8. If we look at the 99% confidence interval, and we go down to 1, 2, 3, 4, 5, 6, 7, 8. We're looking at, you can see it here, 3.355 plus and minus 3.355. And then we would say that is equal to the data minus mean over standard deviation. And we would fill in for the mean and the standard deviation eventually when we actually do a question. But right now, our main concern is, do you know how to get that particular value for a 99% confidence interval? Last lesson, we only found these for sample sizes of 30 or more, but right now we're actually now adding to it if we have a sample size of less than 30. So we'd like to create a 95% confidence interval for a sample size of 34. Now you may say, well, the degree of freedom is 1 less than 34, which is 33. And you would be right for a 95% column, but what I did was I tried to make your life a little nicer so you don't make a mistake. If you go to the 95% column, whoop, there we go, 95%, and we want to go down to 33. So 95%, we want to go down to 33. Now there is a number for 33. It's right here. Right? So there's 33. The problem is you actually don't use this chart, because if anything 30 or more, you actually go to the bottom of the chart, and that's why I labeled this here for you. N greater than or equal to 30. So for 95%, then we're going to go back to our regular traditional plus and minus 1.96 is going to be our z-score. Okay, that's so this chart that I doctored up here with all of these labels is going to be the actual t-chart that you're going to download from the website. So I already put this in there for you, and I attach the PDF file to the website so you have it at your disposal, which is nice. Okay, so same basic steps for confidence intervals. They're exactly the same as we had in the last lesson. So we're going to find the mean and the standard deviation of the sample. We're going to make sure that we use the correct formula, depending if it's a value question or a percentage question. Same formulas that we had in the last lesson. Using the z-score equals data minus mean divided by standard deviation formula, we're going to substitute in for the z-score and the mean and the standard deviation. And then we're going to solve it exactly the same way we did in the last lesson. So everything's the same. The only new thing is that the z-score sometimes changes, and that is based on, again, the sample size. All right, so let's do a couple problems here. Okay, so here's a problem. Okay. A random sample of finishing time for a sample of runners for a 15K race are. Okay, these are the sample of finishing times in minutes for some runners. If you notice, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 runners. So our sample size is 11 runners. And so our degree of freedom is going to be 10, one less than 11. That's going to come in handy when we go to solve this actual question. So what is the point estimate for mu? The point estimate, you know, is another way of saying what is the sample mean. Okay, and we're going to do the same steps that we did before. So step 1 is always find the mean and find the standard deviation. Well, what we're going to have to do is we're going to have to store these in our calculator, because there's no other way to find the mean and the standard deviation. So here we go. Okay, we go to stat, we go edit. If I have anything in my lists, I clear them out. Okay, remember, highlight the list and then hit the clear button right here. Okay, and we're going to put in 72.3, 56.6, 85.7, 46.3, 76.8, 93.6, 88.5, 69.4, and 56.8. Okay, we have them all in there, so now we go to stat, we go to calculate, and then we have to put in again the L1, because that's where I stored all the data, and we get back a mean of 72.63. And a standard deviation of, right here, 14.58. So that's our sample. That's one sample. If you recall, now this is a value question because these are all minutes. If you recall, we still have to now take a guess as to all runners. So we need a mu sub x bar, which is the mean of all runners, and we're going to keep that mean the same. But now we have to change the standard deviation, and we have to take the standard deviation and divide by the radical sample size, and the sample size was 11. So we still have to do that. So we're going to, in our calculators, we're going to put in 14.58, and we're going to divide that by the square root of 11. And we're going to get back 4.396. We're going to call that 4.40. So there's our mean and standard deviation. So when they ask for the point estimate for part A, go over here, that is going to be the mean, which is 72.63. B, they ask create a 90% confidence interval. So we'd like a 90% with a degree of freedom of 10. If we go to 90%, degree of freedom of 10, we're looking at 1.812 for our z-score. So 1.812 is our z, and we're going to say that is equal to the data minus the mean, we know, and the standard deviation of 4.40. So then we're going to do the left piece of data, negative 1.812, and then we're going to get rid of the division by multiplication and get rid of the subtraction by addition. And then we're also going to have a right piece of data. We're going to do the same thing but with a positive z-score. And if you recall, this is exactly the same stuff that we did in the last lesson. The only difference is that this z-score is based on a 90% confidence interval, but the sample size is 11, so the degree of freedom is 10. Okay, so in our calculators, we're going to put in negative 1.812 times 4.40, and we're going to add 72.63. 64.66. And then we're going to do the same thing with the positive 1.812. We're going to get back 80.60. Okay. Question C asks us to explain our answer to part B. So we're going to say we are 90% confident the average finishing time for all runners is between 64.66 and 80.60 minutes. D asks, what is the error? So if you recall, we're going to take the mean of 72.63, and how much do we have to add in or subtract to get those endpoints? So if we take the endpoint of 80.60 and we subtract the 72.63, or if we take the 64.66 endpoint and subtract the 72.63, you would do only one of those. You're going to get back plus or minus 7.97. So if we add 7.97, we'll get that endpoint. If we subtract, we'll get that endpoint. So the error is plus or minus 7.97. And if you recall, for 90% confidence interval, that is called maximum error. And then for part E, what percentage of the time, we'll scoot up here, what percentage of the time is the interval created in part B wrong? Well, if we're 90% confident, then we're 10% not confident. So there's a 10% chance that it's wrong. So there's our confidence intervals. Okay? So let's do a similar question. I'm going to sit it here. We're going to read it together, and then I think a good idea would be for you to pause the videotape once we read it, and I'd like you to do this question and see if you can come up with the answers, and then again click it back on and see if you're right. So a concessions manager at a local movie theater wants to know the average amount of money spent per purchase. So the manager took a random sample of 17 people and he found the following purchases. So there's the purchases for 17 individuals. Okay. What is the point estimate for mu? Point estimate is another way of saying what is the sample mean. We'll switch to red here. Well, we don't know what that is, so we have to find the mean and the standard deviation of these 17 people, so we're going to have to put those into our calculator. So here we go. We're going to go to Stat. We're going to edit. We're going to clear out the data we just put in the last question, and then we're going to put in 17.10, 12.45, 27.15, 5.25, 10.60, 9.50, 11.75, 36.85, 19.55, 18.65, 30.90, 25.81, 5.25, 18.50, and then 12.60. I can't see, that's why I got to move the calculator a little bit. 21.25, and finally 14.60. Okay, so I got them all in there. So we're going to hit Stat. We're going to go to Calculate, and we're going to hit L1 for our column, and we're getting back a mean of 17.52. So X bar, and a standard deviation of SX 8.80. So that's one sample. So now we want to predict as to all people that are going to spend money at this concession. So we're going to say the mean of all people is still 1752, but the standard deviation is going to be this previous standard deviation of 880, and we're going to divide that by the radical sample size. So we're going to take 8.80 and divide by the square root of 17. We're getting back 2.13. So that's our mean, that's our standard deviation. Mean and standard deviation that we're going to use for the question. So part A says, what is the point estimate? That's going to be the mean, which is 1752. Okay. Part B now says, all right, let's create a 95% confidence interval. Well, 95% confidence interval is going to be then the 0.025 in the right tail, and the degree of freedom is going to be 1 less than 17, 16. So we go to our T-chart. 0.025 in the tail is 95% column. We're going to go down to a degree of freedom of 16. So here we go. 16. There we go. 2.120. 2.120 is our z-score. That's equal to data minus the mean 1752 over the standard deviation of 2.13. So we're going to take the negative z-score. We're going to multiply by 2.13 to get rid of the division, and we're going to add 1752 to get rid of the subtraction. And then we're going to take positive 2.120 and again multiply and add. We're almost there. Okay, negative 2.12. We're going to multiply by 2.13, add 1752. We're getting back 13.00. And then 2.12, we're going to multiply by 2.13 and add 1752. We're getting back 22.04. And that's our interval that surrounds the average, and we're 95% confident that the average of all people is going to be within that range. Now remember, we're not saying 95% of people spend between this much. We're saying the average is within there. Okay, so part C says, again, similar to last question, explain your answer. So we will say, we are 95% confident the average amount of money spent on concession is between 13 and 22.04. So the average is somewhere in that range. D, what is the error? We go up here and we put the average of 1752 and we figure out how much do I have to add and subtract to get the endpoints. And I think it's going to turn out to be 452. If we add 452 to there and subtract 452 to there, we'll get back those endpoints from the mean of 1752. So the error is the 452, and this is a 95, so that's going to be margin of error, because that is what's used only for 95% confidence intervals. And then for part E, where it says what percentage of the time is this interval going to be wrong, 95% confidence gives us 5% chance of being wrong. Alright, so I hope you did well. Okay, there's the answers. Scroll up a little bit. Alright, let's do one more. Since we live in New York, a lot of people are Yankee fans, so we're going to do a Yankee question. A random sample of 22 Yankee games found that they scored the following number of runs per game. And here's the run for the first game, second game, third game, all the way through to the 22nd game. We would like to have a confidence interval for how many runs they're going to score, you know, for the whole season, let's say. So what is, again, same basic 5 questions. What is the point estimate for mu? And we're going to create a 99% confidence interval. We're going to explain the answer. We're going to find out what the error is, and we're going to find what percentage of the time is the interval going to be wrong. Well, we know that if it's a 99% confidence interval, then the answer to party is going to be 1%. That makes sense. All right, so step 1, we need to find a mean, x bar, and a standard deviation, because this is a value question of sigma n minus 1. All right, so we're going to have to put in, scoot this paper over a little bit. All right, so going back to stat, we're going to edit, we're going to clear. Okay, and we got to put in all these numbers here. So we're looking at 2 and 3 and 5 and 8 and 1 and 0 and 6 and 5 and 7 and 8 and 5 and 2 and 6 and 5, 2 and 9, 5 and 4, 6 and 2 and 13 and 9. Okay, so there's all of the data in there. Okay, once we get all stored in there, we're going to calculate one variable, and we're going to put in L1, and we're getting back a mean of 5.14. So that's the average number of runs over those 22 games. And the standard deviation SX is 3.11. Okay. This is for the sample of 22 games. Now we want to predict all games. So we're going to say the mean is going to be 5.14. The standard deviation we're going to take to be the 3.11 standard deviation divided by the square root of the sample size, which was 22 games. So in our calculator we're going to put in 3.11, and we're going to divide by the square root of 22. We're going to get back 0.66. Okay, so there's our mean and our standard deviation we're going to use for the question. So we want to create a 99% confidence interval. So that means the left tail is going to be 0.5%, and the degree of freedom is going to be 1 less than 22, which is 21. So we scoot over here to our t-chart, 99% confidence interval, and we have to go down to a degree of freedom of 21. Scoot it over just a smidge. There's the 21. Let's see if I can get both of those on the screen here. There we go, 99%, and there's my finger, 21. 2.831, and that's our z-score. So plus and minus 2.831 is data minus the mean over the standard deviation. So for part A, we didn't answer part A. The point estimate is the average, so we're going to say the point estimate is 5.14. Part B, we're creating a 99% confidence interval, so we looked up that for the z-score. And we're going to say negative 2.831. We're going to multiply and add. And then we're going to do the same thing with the positive. Okay. So negative 2.831. Whoop, let me clear. Negative 2.831, we're going to multiply by 0.66, and then we're going to add 5.14. And we're looking at 3.27. And then we want to do the same thing to the 2.831. We're going to multiply by 0.66 and add 5.14. 7.01. Now remember, we're 99% confidence interval, so in order to be 99% confident, we have to get a pretty wide range so that creates a 99% confidence interval. So C asks to explain this, so we're going to say we are 99% confident. The average runs per game is somewhere between 3.27 and 7.01. That's going to be the average for the whole year. Now that, like I said, that's a pretty wide range, but that's because of two things. 99% confidence interval is very high, and the sample size was pretty small. So in order for a sample size, a small sample size, to be accurate, which is not as accurate as a large sample size, you have to have a pretty wide width. D, what is the error? Well, we take the mean, 5.14, we place it in between the intervals we created, and we try and figure out how much do I have to add or subtract to get those endpoints. So if you take one of the two, 7.01, and we subtract the middle of 5.14, or you take the other endpoint and subtract the middle, and either way you're going to get the difference of 1.87. So we're saying if we add 1.87 from the mean, we'll get that endpoint, and if we subtract the 1.87 from the mean, you'll get that endpoint. So that's the error. So plus and minus 1.87, that's going to be called maximum error due to it's a 99% confidence interval. And then E, 1% of the time it's going to be wrong because we're 99% confident. So we did pretty good. The last two lessons we're talking about confidence intervals. We want to create a area around the average so that we're a little bit more confident where the population mean is going to lie. So for this particular one, that was the question with the Yankee games. And we did the work. They turned out to be pretty nice. Okay, and there's all the answers right there. Scoot up a little bit for you. And there we go. Okay.